Right, so during this section we're going to take a look at acids and alkalis. Now, first and foremost, acids are substances that have a pH below 7 and turn universal indicator yellow, orange or red. They'll turn litmus paper red and generally form solutions containing hydrogen ions, which are the H plus ions. Hydrochloric acid is known as a strong acid, and ethanoic acid, which you will know as vinegar, is known as a weak acid. And they're just two different types, but there are many different acids out there. Right, alkalis are substances that generally will have a pH above 7, and they'll turn universal indicator either blue or purple. They'll turn litmus paper blue. They can neutralise acids, and they form solutions containing hydroxide ions, which are OH-. So if you see the OH- ion, then you know that you're dealing with an alkali. Examples of alkalis are sodium hydroxide, which is a strong alkali, and ammonia, which is known as a weak alkali, and that produces a very, very small change in pH, around about 9 or 10, but we'll come to that in a little while. Right, the next little part is to look at bases. Now, a base is a substance that will be able to react with an acid, and you don't have to be an alkali to be a base. For example, calcium carbonate is a base, but you can't dissolve calcium carbonate in water, so we can't call it an alkali. So the textbook definition of a base is something that reacts with an acid. An alkali is just a base that can be dissolved in water and produces OH- ions. So for example, just to clarify, calcium carbonate's a base because it reacts with acids, but calcium carbonate's not an alkali because it doesn't dissolve in water. Another example would be sodium hydroxide. That is a base because it reacts with acids, and it is an alkali because it dissolves in water as well. So that just clarifies the difference between a base and an alkali. Bases react with acids, alkalis also react with acids, but they dissolve in water, whereas bases don't. Right, indicators are something you've probably looked at in Year 7. The first thing to note is that an indicator is a substance that will change colour in the presence of acid or alkali. Geranium plants have red flowers if grown in acidic soil, whereas if grown in alkaline soil they'll have blue flowers, and they are obviously an indicator as a result of that. The most common indicator you'll have probably seen lower down school is universal indicator, and that gives you a colour depending on the strength of the acid or the alkali. Now the pH scale kind of links into that. In the pH scale, it's a measure of how acidic or alkaline a substance is. Now if something's got a pH of 7, we class it as being neutral, and then if you go below 7 it's an acid. The further away from 7 you get, the more acidic it becomes. And then above 7 is an alkali, and the further away from 7 you get, the stronger the alkali becomes. Now if we look at all of these substances that you will probably know from everyday life, all of them have a sort of acidity or an alkalinity, or they are neutral. So the very, very strong acid here is sulfuric acid, pH of 1. Stomach acid is the next, then lemon juice, and as you can see, as you get closer to 7 the acid gets weaker. At 7 you've got water, that's neutral, and then weak alkali, toothpaste, slightly stronger, ammonia, and then very strong alkali, sodium hydroxide. Now the pH scale is used to tell us how strong the acid or alkali is, but also if we use universal indicator we can see the colour will tell us how strong the acid or alkali is. So if you use universal indicator and it turns red, then you know it's a strong acid. If it turns yellow, then you know it's a weak acid. If it turns blue, then it's sort of a strongish alkali. If it turns purple, then it's a very strong alkali. Right, okay, this is just a review of what we've done so far, so if you want to pause the video and just write true or false for the following 6 statements, then we'll check those in a second. Right, hopefully you've had a chance to check those, and these are your answers. So an alkali is an insoluble base, that's false. An alkali is a soluble base. All metal hydroxides react with acids is true. Alkalis contain H plus ions is false, they contain OH minus ions. Acids contain H plus ions is true. Hydrochloric acid is a weak acid, false, it's a strong acid. And ammonia solution is an alkali, that is true as well. Right, the next section is making salts. Now we're going to start with a simple example. If you react an acid and a base, you get a salt, and usually you get water as well. Now the rule is pretty simple. When you get a salt, the first part of the salt's name comes from the metal that is in the base. So when you see sodium hydroxide, that's going to form a sodium salt. And then what you do is you take the acid that you're reacting it with, and that will give you the second part of the salt. So sulfuric acid will always give a sulfate, nitric acid will always give a nitrate, and hydrochloric acid will always give a chloride, and they're the 3 acids that you need to know. So in this case, with using sodium hydroxide and sulfuric acid, I'm going to get sodium sulfate. If I'd have used nitric acid, I would have got sodium nitrate. If I'd have used hydrochloric acid, I would have got sodium chloride. Right, so here are some examples of acids and bases reacting together. And what you've got to do, you've got to remember that whatever the base we use, it is the metal from that base that we use in the salt. And we'll start off with calcium hydroxide plus hydrochloric acid. Hopefully you can realise that the salt there is going to be calcium chloride because we've used the metal calcium, and then hydrochloric acid gives us a chloride in our salt. Now what I'm going to recommend is that we'll pause the video now and let you work out the name of the following 4 salts, and then in a couple of moments I'll go over those. Right, hopefully you've had a chance to work those salts out, so very quickly I'll just go through the answers to these. So we start with the second one, magnesium oxide plus nitric acid. Magnesium nitrate is the salt, magnesium being the metal from the base, and nitric acid always gives a nitrate. Against third one, copper oxide plus sulfuric acid, copper from the base, sulfate because of sulfuric acid being used, and then ammonia and nitric acid gives ammonium nitrate, and again nitric acid, nitrate salt, and then potassium hydroxide plus sulfuric acid, again we're going to get a sulfate, and it's potassium sulfate in this case. So acid plus alkali gives us a salt, and it also gives us water. We call that a neutralization reaction because acids and alkalis neutralise each other to make salts and water, and the pH would turn to pH 7 in this case. So we get water because the OH minus ions from the alkali are added to the H plus ions from the acid, and OH minus plus H plus gives H2O. And that's the neutralization equation. Now, if you look at the bottom example here, we've got hydrochloric acid plus sodium hydroxide gives me the salt sodium chloride plus water. And as you can see, chloride because I've used hydrochloric acid, and the sodiums come from the fact that I've used sodium hydroxide. Another thing to note at this point is that my salt that I've made has the state symbol AQ at the side of it. Now AQ means aqueous, which means dissolved in water. And what that means is that this salt is a soluble salt, and a soluble salt is just a salt that will dissolve in water quite well. You can get some salts that are insoluble that don't dissolve in water, and we'll look at some of those in a minute. Right, the next example you need to know is what happens if you add an acid to a metal. So we've added an acid to a metal hydroxide previously. Now we're adding an acid to a metal. Again, we still get a salt, but instead of getting water, this time we get hydrogen. So an example of this would be hydrochloric acid plus zinc metal, and the salt comes from, again, the metal and the acid combining, so zinc and then chloride because we've used hydrochloric acid. And the gas given off is hydrogen, and you'll probably know from lower down school that to test for hydrogen gas, we take a lighted splint and we place that in the test tube containing the hydrogen gas, and we should hear like a squeaky pop, something along them lines. Third type of reaction that you need to know is acid plus metal oxide. Now, this is exactly the same reaction as what happens when you add acid plus metal hydroxide. You get a salt and water as well, and it's a neutralization reaction. So the easy one to use here is hydrochloric acid plus calcium oxide. Now again, if you look at the salt produced, we get calcium chloride. Why? Well, the calcium comes from the actual base, the metal always comes from the base. And then the chloride, yes, you guessed it, comes from the fact that we've used hydrochloric acid, and water is produced as well because it's neutralization. Right, the next part is just to sort of review what we've already said. Now, it's another example of adding a metal oxide to an acid, only we're going to go into a little bit more detail now. So we're using sulfuric acid and copper oxide this time. So I'll look at my salt. It's got my metal from the base, and sulfate because I've used sulfuric acid, and again I've got the water because it's a neutralization reaction. Now the important thing here is we've got a soluble salt. Now in the exam, you could well be asked, how do we get a soluble salt back from the water once it's dissolved? And we're going to talk you through how you would do this. So, starting from the beginning, we've got our sulfuric acid and our copper oxide. So what we're going to do, we're going to mix them together. And generally what happens is your sulfuric acid and your copper oxide will react together. Now the idea is that we'll make copper sulfate, and that salt is a soluble salt. So what we're going to need to do is we're going to need to get that salt out of the water to be able to get it back. So the first thing we do with a soluble salt is we always will filter it first of all. And the reason why we filter it is to remove any solid impurities. So what's going to happen now, the solution is now going to be poured through filter paper and a filter funnel. And what will happen is very, very important. The soluble salt, the copper sulfate, which is dissolved in the water, passes straight through the filter paper. So inside the bottom of this evaporating basin, I've got copper sulfate and water. Now just going back to the previous slide, we've got copper sulfate and water being produced by this reaction. And at the bottom of my evaporating basin, that's what I've actually got. In the filter paper are just unreacted pieces of copper oxide that I don't want, and they've been filtered out. Now what we have to do, in order to get the water away from the copper sulfate, we have to leave the evaporating basin either on a windowsill to evaporate steadily, or if we want to do it quickly, we heat it, and that will evaporate the water away. And what will happen is, at the end of the process, left behind will be my copper sulfate salt on its own with nothing else. So what I'm doing here essentially is heating it to get rid of the water, and what's happening is my copper sulfate salt is forming, and this process is called evaporation. And they could ask you in the exam, how do you separate a soluble salt from its water that it's present in when it's in the solution? It's just by heating and evaporating, using an evaporating basin, and evaporate the water away, and you'll be left with your salt behind. But remember, we filter it first to remove any solid impurities that we don't want. Right, so just to summarise, there are 4 ways of making salts from acids, but for AQA we only need to know 3 of them. So the first one is acid plus alkali gives salt and water, acid plus metal gives salt and hydrogen, and acid plus metal oxide gives salt and water as well. They're the 4 that you need to remember, and you also need to be aware of how to work out your salt. But again, if you use your common sense, work out the acid that you're using, then you can work out the salt from that. Nitric acid gives a nitrate, hydrochloric acid gives a chloride, and sulfuric acid will of course give a sulfate. Right, so here are a series of reactions where you have to match up the reactants, i.e. the acid and the base, to the salt that we're going to get from that. Now, what I recommend here is if you pause the video and match them up yourself, and then we'll reveal the answers in a moment. Right, hopefully you've had an opportunity to do that, and you've probably realised that the majority of them are easy enough to spot. Sulfuric acid and potassium hydroxide, potassium sulfate, HCl plus NaOH is NaCl, phosphoric acid plus sodium hydroxide, okay, that's not in the AQA syllabus, but I would like to think that you'd get that as being sodium phosphate. HCl plus ammonium hydroxide is NH4Cl, hydrochloric acid plus copper carbonate gives copper chloride, and H2SO4 plus ZNO would give ZnSO4. So they're the types of reaction that you'd be expected to know. Right, in these cases we're just going to run through very quickly an example of some of these neutralization reactions. So it's simple to start off with. Something plus hydrochloric acid gives sodium chloride and water. So they've given you the formula for it is NaOH, and hopefully you'll realise that's sodium hydroxide, which is an alkali, and then sodium chloride has the symbol NaCl. Second reaction, zinc oxide plus hydrochloric acid gives something plus water. The formula is ZnCl2. So looking at that, you can work out that it's going to be zinc chloride because hydrochloric acid will always give a chloride, and the formula for hydrochloric acid is HCl. Notice I need 2 of them to balance the equation. Right, the third reaction, sodium hydroxide plus sulfuric acid gives something plus water. Hopefully we'll realise that it is sodium sulfate, and that is the formula Na2SO4. Most important at this point though is to make sure you know you're going to get a sulfate from the sulfuric acid. Right, next one, something plus hydrochloric acid gives ammonium chloride plus water. Hopefully when we look at that we can see that we're going to be using ammonium hydroxide, which is NH4OH. The key to this is you've got to use a hydroxide. You can't use ammonium nitrate, so we haven't even done that. Ammonium hydroxide plus an acid gives ammonium chloride. Why is it chloride? Because of hydrochloric acid. And final example, calcium hydroxide plus nitric acid will give calcium nitrate plus the water, and calcium hydroxide is CaOH2, which is that. So hopefully we've given you a bit of an idea. What I don't want to do at this stage is to scare people, because the most important point there is to be able to work out the salts that are formed. They're not going to be asking you to write ridiculously long equations. They're going to be expecting you to realise that when you use certain types of acid, you're going to get certain types of salts from that. Right, precipitation reactions. Now, precipitation reactions are where you make a salt that is not soluble. Now, the problem with these reactions is the salt itself does not dissolve in water. So in this case, we've shown an example here where lead nitrate and sodium chloride have been added together. They're both aqueous. And what we'll notice with our salt, lead chloride, is it's solid. Now that means that it does not dissolve in water. And when you get a solid produced that doesn't dissolve, we call it, the name for it is a precipitate. Now, in order to get that precipitate back, what I have to do is carry out a process called filtration. And what happens is you've got your precipitate and water in the beaker, you pour it through the filter paper, and what will happen is the solid that doesn't dissolve will be captured in the filter paper, and then the rest of the impurities will dribble through. And what you do is you then wash that salt with water to remove any soluble impurities, and then you would leave it to dry, and then you've hopefully got a fairly pure salt from that. So you filter it, wash it with water, dry on filter paper, and that will get you your insoluble salt back from the solution. How do you know it's insoluble? Well, you'll see the symbol S at the side of the salt. That tells you it doesn't dissolve. So we can't just use evaporation like we did before. We've got to filter it and wash it because it's an insoluble salt due to the solid state symbol that we see there.